As you know, with every lesson, we have a set of learning objectives. So let's take a look at what we've got lined up for today's lesson. We are going to start off by defining the blueprint, looking at exactly what the blueprint is. We are then going to analyze and define measurement and look at what measurement is to us as designers. We're then going to analyze and define the idea of scale. And we will end off by applying the knowledge of scale by using our very own scale ruler. Here is the quote that I have for you for today's lesson. Let's check it out. "The details are not details. They make the design," by Charles Eames. You should remember this name, Charles Eames, from our previous module where we spoke about the Eames chair. Well, this quote has such a beautiful message. In fact, it's asking us to really think about what detail really is. What is detail and how does it translate into our designs? It requires thought, and that's where measurement and scale come in. Accurate information from on-site research provide us with accurate information to build on, ensuring our details in the space are correct and work in that space, which make our designs functional in the best possible manner. There are a couple of things that I'd like you to grab for today's lesson. Let's take a look at what they are. Starting with your sketchbook, grab some pens and pencils, your eraser, a computer. So for module 3, we are going to be shifting our focus onto CAD, computer-aided software, and for this you are going to need your computer. I'd then like you to grab a tape measure, and then obviously, as you know, a nice large surface where you can work and feel comfortable to get your design juices flowing. For this lesson, we have a fun, jam-packed lesson filled with some exciting content. This is what you can expect. Topic 1, we are going to look at the blueprint. Topic 2, we are going to focus on measurement. And topic 3, we are going to look at scale. Let's dive right in. We are going to kickstart this lesson as we start off with our first topic, the blueprint, looking at an introduction to the blueprint and how it's valuable to us as interior designers. First things first, as we've learned in previous lessons, part of our responsibility as the designer working on any project is to produce drawings for these projects. So we haven't really discussed this in too much depth in our previous modules, and that's what makes module 3 such a super exciting module as we look at everything about our drawing work and what we need and what we use to create some of these drawings for any project. The drawings that we create for our projects, whether that be for a small office space, a renovation, a lounge plan, right through to a massive hotel or large corporate space and construction, are called our drawing packs. These drawing packs can also be referred to as our technical drawings, our construction drawings, and our blueprints. Each of these names can be used interchangeably to refer to our drawing packs. So the obvious question here is, what is a drawing pack or blueprint? Do you know what a blueprint is? Think about it. It's all in the name. Break up the word. The blueprint is a set of technical drawings. It could be one or many, depending on how many details and drawings are required by the designer or the architect drawing up the project. The blueprint, technical drawing, or construction drawings, which are all words that can be used interchangeably to describe your drawing pack, contain all the necessary information required to reproduce that project into reality. The blueprint is a program of action, if you will, or a roadmap and guideline. It describes exactly what needs to happen on a project, right from the color of the walls to each of the elements that is going to be brought into that space or constructed. I always like to look at a definition of our core topic. So here is a definition from Merriam-Webster of a blueprint. A photographic print on white on a bright blue background or a blue on white background used especially for copying maps, mechanical drawings, and architectural plans. On your screen is an example of a blueprint drawing. This is a technical drawing mapping out everything that needs to happen for the structure to be constructed by the contracting team or manufacturing team. Exciting, right? To think that a single set of drawings will essentially produce an entire building or space. Did you know blueprints were invented a generation before the Civil War by John Herschel, a chemist, astronomer, and photographer in 1842? But why are they called blueprints? Really nicely explained by DCM drawing specialists, a process invented in 1861 by French chemist Alphonse Louis Poitevin, used properties of light-sensitive gum that turns blue to create a process to copy paper documents to paper or other materials. The result is a blue negative conversion where the black lines become white and the background white color becomes blue. Therefore, we get the blueprint. As we know, the blueprint drawing pack or construction pack are a set of documents that we as designers used to create and represent and portray our designs for manufacture and construction purposes. Let me introduce you to your new best friend, measurement and scale. On every drawing you create throughout your career as interior designers, you are going to use one, if not both of these elements on your blueprints and on your drawing packs. Blueprints are so important to various people working on your projects. But why? Can any of you tell me? You can pop your answers into your Morpheus text box. Think about it. Why is the blueprint so important to your project? What elements stick out for you? The key importance of your blueprint are as follows. Firstly, your blueprint ensures consistency. It ensures that everyone working on that project is on the same page, reading from the same book, all instructed to create that one single project from one document, which in turn ensures consistency. This is relevant right from the contractor, the construction worker, the fabricator, to the homeowner, building owner, and building inspectors. Secondly, your blueprint aids in the approval process. They are vital for your client's approval steps in your project. They form a sort of contract per se. One document highlighting what has been promised to be constructed or manufactured in one single document. That will then be approved and signed off by both client and service provider. Then your blueprint assists in cost estimates or cost generation. It assists in calculating the costs of materials and labor that will be carried out on that project. Next, your blueprint aids in obtaining a building permit, a really important step in the process. These documents are generally sent off to your city council or local authority for approval. A set of blueprints must show your building design in compliance with your local building codes, or the building inspection department is not going to approve your building request. And lastly, your blueprint ensures that there's an overall precision, documented rules and regulations of how that project needs to be carried out right from the start to the finish. So as you can see, it's a form of contract, a document that houses all the vital information necessary for construction. With the understanding of the importance of the blueprint drawing, we need to understand that accuracy here is of key importance on your drawings. Some of the drawings that make up your blueprint are your plan, your section, and your elevation drawings, and therefore accuracy applies here too. We are going to start with looking at the concept of accuracy of size on a project or on our drawings. Whether that be your plan, your elevation, your section, or a detail, there is a level of accuracy that we need to add to any drawing. What I mean by this is, as you know, as interior designers, it is our responsibility to ensure that we produce accurate drawings. Accuracy in the way that they have been created, and accuracy in the way that they will be produced. This means that the information that we provide to the various parties using our drawings needs to be precise and correct at all times. There are many elements of a drawing that will assist in ensuring accuracy, but some of the main focus points here will need to be on your measurement, your dimension, and the scale allocated to your drawings. The drawings that you as the draftsperson or designer have created needs to be communicating the exact size that the end result needs to be produced to, and your measurements, dimension, and scale is all going to lead to that. The primary focus, however, is that without measurement, accurate scale, and dimension on one's drawings and design projects, we end up with inaccurate information which could lead to a poorly designed or planned space. This is obviously something that we as designers need to avoid. We are going to critically analyze each of these elements before we carry out our site survey in Lesson 2. So make sure that you have your sketchbooks handy and ready. Let's dive right in. Just a little heads up before our next lesson. Lesson 2 is going to be using our measurement and scale to set up and conduct our very own site surveys. We are going to survey up a project and document our findings. This is one of my favorite elements to produce or create on any project, and I look forward to guiding you through this process. But that's only for Lesson 2. Let's get back into our measurements. We are going to start off with looking at the concept of measurement and tackling this element in our very first example, starting off by understanding the meaning of measurements versus measuring. There are two elements that we need to focus and look at when it comes to our measurements. a measurement, and to measure something. Firstly, our noun, a measurement, the numerical value given to a size of a space. The verb, measuring, taking measurements. Both are equally important to us as designers and to our site surveys. Measurements are now going to become your new best friends during your career as an interior designer. They are like the tennis racket to the tennis player, the paintbrush to the artist, or even the flower to your cake. We are going to take a look at what each of these measurements mean, starting off with the term a measurement. Can any of you tell me what a measurement means? What does it mean when I say a measurement? I'm sure to most of you it seems like a very obvious answer. However, I want you to really think about measurement and its impact on us as designers and our projects. And you can use this to answer your question. Pop your answers into your Morpheus text box. Make a note for yourself in your sketchbook. This may be an assignment question, just a heads up. A measurement is defined as the numerical value used to indicate size of a space or object. It's the numerical value that provides size such as height, width, and depth on our projects. The key terms that are vitally important to us in this definition are as follows: numerical value and size. In essence and in simple terms, measurement means to understand the size of an object and space and note it. We then take a look at the noun, to measure, to take measurements. This is the act of recording a size of a space or of an object. The action of measuring something, the size, length, or amount of something, as established by measuring. It is our responsibility as the professional or designer on a project to gather measurements relevant to your project by performing the action of measuring the space, and this takes place during your site survey. Here's a little example and scenario for you. Your client, Vanessa, is renovating her hair salon. She has sent you a request to start drawing up an accurately sized, proportionate, and scaled floor plan for her space, and she would like you to send her some space planning options. The first step here is to start drawing up the existing premises and then create some layout options on your CAD program or even by hand based on the existing dimensions and space survey. But where do you start? You've got no measurements and no idea of what the space looks like. Your solution is, we need to gather information in the format of a site survey and gather all the relevant measurements relating to that space to be able to draw it up. That is where your measurements and taking measurements come into play. We need to know the measurements of that space to be able to construct or draw an accurately dimensioned drawing. Now we know exactly what measurements are and what taking measurements mean. Let's understand why they are so important to us as designers and on our projects. Measurement in the world of design and architecture is everything, and specifically relating to accuracy when it comes to planning your projects and providing information to your clients and teams working on these projects. Measurement is important to us as designers to be able to accurately construct drawings, drawing up our projects, including relevant information and not leaving anything out to chance. With our measurements, we can draw up a room with the correct sizing to scale and add all the various elements in to establish whether or not each element will fit and to create a well-designed space. Secondly, measurement is important to us as it allows us to provide accurate information. It helps us advise on information relating to elements in the project. We can provide accurate information on size, scale, and dimension to anyone asking about that space. This is really important and a vital element, one that I find myself doing daily. For example, how many meters is that wall? A contractor may ask you. I can then respond instantly as I have all my dimensions noted down in my sketchbook from my site survey, from taking the measurements of that space. And thirdly, the important element of measurement is it allows us to add accurate detail. It allows us to add elements to a project and draw with ease. Accurate measurement assists in overall design processes. So now imagine this. Your client Vanessa has now just phoned you regarding her salon and her renovation and asks if her 2 meter by 2 meter by 3 meter desk is going to fit on the far left-hand side of her space. How on earth are we going to answer this question with precision and accuracy? Remember, if you provide an inaccurate information or inaccurate drawing, generally this will cause a problem on site and a very unhappy customer. You need to make sure that the measurements of the space are accurate. make sure that the measurement for this reception desk is in fact going to fit in the space, and then you can provide Vanessa with factual and correct answers. The short answer to this is that you need to take accurate measurements and provide Vanessa with accurately based answers. Right, so now that we've covered measurements and why they're important to us, let's take a look at the tools we can use to obtain these measurements on our projects, whether that be a space, an object, or a project site. The primary tool set that one would need to take measurements or use to conduct your survey are your tape measure and a simple pen and paper. Your tape measure is used to physically assess the space size. You ideally want to get your hands on a heavy-duty tape measure, which you can find at your local hardware store or stationery store. You want to make sure that you've got at least 6 meters or 19 feet on your tape. A tape measure obviously comes in a variety of units of measurements according to your work and the country that you're working in. Please make sure that you are able to get the right units to your country. And then your pen and paper. This is going to help you notate all the measurements after you've made use of your tape measure. So once you've conducted your site survey, you've got a measurement. For instance, let's say the wall height is 10 meters. You will then note that down with a pen and paper, or even better, in your sketchbooks. On your screen is what a tape measure looks like. You should all know what a tape measure is, guys. I strongly recommend that you invest in one of these. I've got a variety of tape measures in every single one of my bags, in my car, in my work bag, in my handbag, everywhere, and I use them all the time. I always want to know the heights, widths, and depths of the project that I'm working on, and it's really useful when a client asks, what is the height of this? I can quickly whip my tape measure out, give them the height, width, or depth of whatever they are looking at the time. A tip of the trade, I like to make sure that I take all of my own measurements relating to any project that I'm working on, or cross-check all the dimensions taken from another designer or contracting team. This is pick scale. With measurement comes the all-important partner, scale. Measurement is going to provide us the size and value of elements in the real world, where scale is going to assist us with putting those measurements onto paper. So, do you know what scale is? Think about it. Maybe you've heard of the term before, but can you explain what scale really means? You can pop your answers into your Morpheus text box or make a note for yourselves in your sketchbooks. What is scale? On your screen is a house with people enjoying the space within the house. Now have a look at this drawing. This is a drawing of that exact house. These are the plans that were used to create this house or construct this house. The dimensions on this drawing or on the blueprint are dimensions to reality. But how is that possible? For example, on your drawing, it might have a dimension of 10 meters. But in reality, if we took a measurement or a ruler and measured that, that is not 10 meters. But how is that possible? That is the concept of scale. Scale is the tool that we use as designers, architects, and engineers to convert the actual size in reality to a suitable scaled size onto our drawings. The key here is that we're able to achieve accurate measurement on our drawing, depicting the actual size of the project onto a reasonably sized piece of paper. In essence, the scale on your drawing will allow objects in reality to be accurately represented at a fixed scale, which can then be measured with a scale ruler to determine the actual size of reality. On your screen is a definition of scale from CAD for you. A scale is defined as the ratio of the linear dimension of the object as represented in a drawing to the actual dimension of the scale. The key takeaway terms here to focus on when discussing scale are your ratio, accurate size, and actual size. So the concept of scale is built around the idea that the actual size of an object, building, or element that you are drawing is drawn on your page in a smaller or much larger scale set of dimensions to that of reality, to make sure that we can work with a workable or a easily workable sized piece of paper or drawing. But when read in conjunction with your scale ruler, they represent the same size as reality. So in essence, the size of an object on your page is a fraction or a ratio of the size to that of reality. So, for example, let's say you had a large dining room table in front of you of 3 meters long by 2 meters deep. it would be virtually impossible to get a piece of paper or a drawing to fit that exact size on that piece of paper. So essentially we'd need a piece of paper of 3 meters by 2 meters. That is just not practical, and that's exactly where scale comes in. Think about a house, for example. This house has a 10-meter high wall. If we draw that wall on a page in its actual size, so the size of reality, 10 meters, we'd need a page size of at least 10 meters, right? Well, that's just not practical. Hence the concept of scale and ratio. It's not convenient always to do a drawing or create a drawing of an object to its actual size. Some ideas of this might be massive buildings, large bridges, heavy machinery, or simply your lounge. And thus the following scales are then applied. You may have noticed we've discussed the concept of ratio and scale quite a lot in the last couple of slides. So what is ratio, you may ask? A ratio tells us how many times one number can go into the other. A ratio shows the relative sizes of 2 or more values. For example, let's say we had 8 slices of cake and 6 muffins on your tea tray. The ratio of this is then 8 to 6. 8 slices of cake to 6 muffins on that tea tray. It could be written as follows: 8 to 6 or 4 is to 3. This is exactly how one would indicate scale on our technical drawings. The number of times the drawing size fits into that size of reality. So the drawing size is a ratio of reality. Let's look at that in technical drawing terms. If my object is 5 centimeters in reality in length, and on my page I'm drawing that same object of 5 centimeters in reality as 1 centimeter on my page, what would the ratio look like? How would I write this ratio? The ratio would look as follows: 1 is to 5. For every 1 centimeter of the object on the page, there are 5 of those in reality. So 5 centimeters in reality. It's important to know how to indicate what scale your drawing has been drawn to or has been created to. So let's start by looking at what scale looks like on a drawing. As we know, the scale of a project is represented in the format of a ratio on your drawing. This ratio will look something like this on your screen. Here's an example of a technical drawing. The ratio is indicated at the bottom left-hand corner, generally, of the drawing. Can you see? As you can see, the scale is represented in the form of a ratio. 1 is to 100. The way that you would say this is exactly like I've just done. 1 is to 100. In this case, you would be looking at a ratio of 1 is to 100. Therefore, your drawing has been drawn 1/100th of the size of reality. A technical drawing can have a variety of different ratios, from 1 is to 1, 1 is to 5, or 1 is to 100. These are just a few of them. There are many possible varieties. Let's take a look at 1 is to 1, the ratio 1 is to 1, or the scale 1 is to 1. This is your starting block ratio, as it means that 1 unit in reality is equivalent to 1 unit on your drawing. So 1 is equal to 1. The unit could be from any unit of measurements. For example, 1 centimeter is equivalent to 1 centimeter, 1 meter is equivalent to 1 meter, 1 foot is equivalent to 1 foot, and so forth. The scale 1 is to 1 is always representative of real life size, or the size in reality. We're going to explain the same concept with the idea of 1 is to 5. 1 in reality is equivalent to a 1/5 on your drawing. Let's use another example. 1 is to 20. 1 is to 20 is 1 in reality is equivalent to 1/20th on your drawing. So if in reality that wall is 20 meters, you would divide the 20 in reality by a 20th, and that would be the length of your wall on your drawing. There is in fact a set of recommended scales that we need to conform to in creating or setting up any technical drawing. This is done to reduce confusion and a mass of scale representation. On your screen is an example of a set of recommended scales by BIS. These are recommended scales that one would typically conform to in setting up your technical drawings. As you can see, we've got 3 categories. We've got your reducing scales, your enlarging scales, and your full scales. As discussed before, your full scale 1 is to 1 is always representative of the scale and size of reality, which means it's equivalent to the size on your drawing. We then look at reducing scales. So reducing scales is typically used in interior design and architectural drawings. Majority of the time we are creating drawings that are much smaller than the actual size of reality. For example, a building. By creating a drawing of a building, we are reducing the scale of reality. And then we get our enlarging scales. So this works in the opposite idea or concept to reducing scales. We use enlarging scales when wanting to enlarge an object on our drawing. So for example, you might have a little needle and that needs to be drawn as a detail drawing. You would enlarge the scale so that we can see the detail on that needle. Some of the common scale that I like to use on my drawing and ones that I recommend for you as well are your reducing scales. The 1:20, 1:50, and your 1:100. You don't have to use these, but these are probably the most commonly used scales. The term scale can also be referred to as the instrument used to measure the various objects or form. Scale can be used to represent a variety of different units of measurement, such as feet, inches, meters, centimeters, and millimeters, as well as so many more. With that being said, why do we use scale? Think about this. Pop your answers into your Morpheus text box. Why do you think we use scale on our drawings? Scale in architecture, engineering, and many other design sectors plays an important role in the execution of one's projects, as well as the initial design and concept development phase. The scale of our drawing needs to be accurate in order to accurately portray information of the space to our client and the contracting teams that will be working on that project. Therefore, we can conclude scale's vital element in our project is that it provides accurate information and accurate dimension. Let's take a look at some of the tools we can use to accurately scale or create scale drawings. When creating our technical drawings, as you know, we have two formats. We can either create computer drawings or manual drawings. When we're using computer-aided software, scaling and dimensioning our drawings is so much easier, as the software has been pre-programmed to scale our drawings. However, when we're sketching or manually creating our drawings, we are totally on our own. But hold on a second. Are we? We actually have a tool that assists us in scaling our drawings to a realistic dimension on our page. Do any of you know what that tool is called? And the term you're looking for is a scale ruler. So, what is a scale ruler then? A scale ruler is a three-sided ruler that is used to convert actual dimensions to a scale drawing or scale drawings to accurate dimensions without having to use maths or to calculate the ratio of the change. On each side of your scale ruler, at the far left hand before the 0 mark, is a number reflecting the scale of the ruler or the dimension on that particular side. Using the appropriate scale is crucial and should be the first step to any project. If reading a drawing, the appropriate scale will be written on your plans. If drafting a plan or creating a plan, choosing an appropriate scale will depend on the size of the drawing compared to the actual dimensions described. So it's our responsibility to make sure that we are selecting an accurate scale when converting our realistic project onto our drawings. Now we know how to scale a drawing. Let's look at how to read a scale drawing. Now, having a solid understanding of what scale is and how it relates to our technical drawings, we are going to take our scale rulers and use them to read a properly or correctly scaled drawing. I'm taking a drawing of a floor plan and I'm going to use this as my example for this lesson. However, please bear in mind this is a generic method to assist reading drawings. Let's say, for instance, we want to know how wide a space is, such as the lounge in this case. Let's see how it's done. Starting off with step 1, you are going to look for the scale. Navigate to the scale on the drawing, find out what it is, and make a note of that. Step 2, you are going to then navigate to the area that you're wanting to dimension. Step 3 is navigate the scale ruler, rotate the scale ruler to the desired scale of the drawing. Step 4 is to then read the scale. Simple, right? Let's see how it's done. Starting with step 1, I'm opening up my drawing and I'm now going to navigate to the scale. So I'm going to find out what scale this drawing has been drawn at. Typically, a scale is housed in your title block. So that's exactly where I'm going to look. And as you see, I zoom in there, this drawing has been drawn at a scale of 1:100. Step 2, I'm going to navigate to the area that I want a dimension for. So at this point, I would like to confirm the width of my bedroom. So I'm navigating to my bedroom. I'm then going to jump onto step 3, where I navigate my scale ruler. So I'm going to collect my scale ruler. From here, I'm going to find the scale that the drawing was drawn to. In our case, I turn the ruler to 1:100. It's not going to be common to find a scale of 1:100 on a ruler. It's not a standard scale size, but this is really easy to solve. You would typically navigate to 1:10. So as you can see, I'm doing. And then simply add a 0 to the measurement that is provided. So as you can see, 1:10. I put the scale ruler onto my drawing. As you can see, 0 from the inside to the outside gets me to 400. That's the width of my room. And then I simply add a 0 onto the end of that, which gives me 4,000, meaning my room width is 4 meters. And that is your step 4, reading the scale. So as you can see, at a scale of 1:10, my room is 400. Adding a 0 onto the end gets me 4,000. And as you know, our drawing is being drawn at a scale of 1:100. Therefore, the room width is 4 meters. Now that we've mastered how to read a scale drawing, it might be a good idea to understand how to create a scale drawing. There's a really nice step-by-step guide that I'm going to include in your summary notes for further reading. I've also included a step-by-step checklist that you can use when scaling your own drawings. Step 1. Take measurements. You need to conduct a site survey of your space or the object that you are wanting to draw up. Step number 2, you need to select a ratio or a scale for the drawing that you're creating. Are you creating a drawing at 1:1, 1:10, 1:100? This you will determine depending on the page size and the drawing that you need to fit onto that page. Step 3, convert the actual measurement with the ratio. Now, this step requires a little bit of brain power. You need to do your conversions. When scaling down, so when using reducing scales, divide the original measurement by the second number on your ratio. So the original measurement needs to be divided by, in this instance, 1:5, it would be divided by 5. In an instance of ratio 1:20, your original measurement would then be divided by 20. And that's that. That is how you go about scaling a drawing. And that's a wrap. Let's take a look at exactly what we've covered in today's lesson. We started off by defining the blueprint and learning everything we needed to know about what a blueprint was. We looked at analyzing and defining measurement, followed by analyzing and defining scale. And lastly, we took our knowledge from this lesson and applied it to using our very own scaled ruler. And from here, we jump into our challenge. Your challenge for today's lesson is a 2-part challenge. Firstly, I'd like you to explain the difference between measurements and taking a measurement. This can be done in a drawing format in your sketchbook, a bullet point write-up, or even a paragraph. Secondly, I'd like you to create a cube of 10 meters by 10 meters or 10 feet by 10 feet in your sketchbooks. You need to choose the scale at which you want to create this drawing to. Don't forget to add the scale at the bottom of your drawing so that we all know what scale you have been working with. Remember, accuracy is key. You can do each of the above elements in your sketchbooks, photograph the outcome, and post it to Shaw Academy Interior Design Facebook page and Instagram account. I can't wait to see what you've been producing. In the spirit of starting a brand new module, I would love to hear back from you. As you know, we have our very own Shaw Academy Interior Design Facebook page and Instagram account where I have seen some amazing work. I'm going to add a post here where I encourage you to write some of the elements of the course that you are really enjoying or elements that you are struggling with and need some assistance. I want to hear what part of the course is inspiring you and which elements are assisting you on your interior design journey. I love hearing from you and I can't wait to get your comments. Let's spread the positivity as we progress